Okay, so KVM high availability regardless of storage. Thank you all for attending this session. Quickly, who am I? I'm Gabriel. I'm software developer at Extreme, which is a Dutch hosting company founded in 2004. I use KVM, Ceph, and CloudStack for a long time, and also contributed to open source. And the first time that I used CloudStack is quite ago as well. I was a committer in 2017, became PMC in 2019, and now current VP at 2021. So let's go to what this presentation brings. So the main focus here is KVM. We're not going to handle both Zen server or VMware. It's just KVM high availability. So to begin with, I'm going to present some background and introduction on the CloudStack KVM high availability. And then we can proceed with the health check with NFS, which is quite important to then raise the main question of this presentation, which is, can we have KVM high availability without NFS? And to answer that, I'm going to present a proposal of KVM high availability regardless of storage. We're trying to construct a new way of checking health of the KVM nodes without going to any kind of storage, being Ceph or NFS, to add a new component. At the end, a quick takeaway, and also aiming at the future, what we can expect in the future for KVM high availability. So let's move on. First of all, why we are presenting this, and why someone could configure and use high availability. I think it's mainly improve quality of service. VM should run as much as possible, and hosts, they should not stay down. They can go down. It can happen, hardware, software, or network failures. And what we want is detect problematic hosts and make sure that the VMs will be restarted on healthy hosts, right? So this is a very simplistic view of how it works, but it's not the entire view. So let's see an case. Let's pretend that CloudStack cannot reach a host. But that not necessarily means that a host is not healthy. There can be healthy VMs running, writing, reading, and storage. Maybe it's just the management network that's not working. And in that case, we want to avoid two VMs mapped to the same storage path. So to do that, we add a recovery or fence step before starting the VMs. By recovery, we mean reboot the host, and fence powering off the host. So that's a very important and critical step. So let's move. These are the high availability states. A health host stays as available. If something goes wrong, it is placed as suspect. And there are a couple of checking. We don't want to straightforward move to recovering or fencing, because it might be a very momentaneous failure, a network issue, or whatever. So, but after a few checks, then we can proceed to recovering or fence. So really quickly here, I'm not going too deep, but we see available hosts, and then it can go to suspect if the health check fails. If it passes, it gets back to available. There are a couple of health checks, but it go back and forth in inspect and checking. And if something goes wrong here, then it can go to recovery, or even skip straightforward to fencing if the admin wants to. He or she can configure it to fencing. So this is always documented. There is the host availability complaints wiki. So anyone can ask me later as well. Okay, requirements. Out-of-band management. This is crucial because it allows to power off or to reboot the host. IPMI is being deprecated by the hardware vendors, so we recommend Redfish, and it's available in CloudStack 4.15 and beyond. And also enable high availability. We need to enable them start offering high availability, and also enable high availability for the host. Otherwise, the host will not be managed, and then it will be placed at the disabled state, which high availability operations are disabled. So let's go back. And of course, use Nfs as a shared primary storage pool. Otherwise, no health check will be performed. Okay, let's move on. Why use Nfs? I mean, why? The main question is, it is a good option actually, because you can have multiple hosts on the same cluster checking the same storage. So if the one host fails, You can get a neighbor host and a host in the same cluster and perform checks on the same storage path, right? That's quite interesting. And that also allows to check the storage activity. And how it works, Heartbeat script running on KVM nodes checks if it can read or write on the mounted NFS partition. It's quite simple. So today, that's how it works. CloudStack sends commands to KVM nodes via the CloudStack agent, which is running in a Java VM. If this agent fails for any reason, or CloudStack loses connection, it transits from up to disconnect state. But that state is different from the high availability states, which we already seen that can be available, suspect, or checking, and goes on. And the NFS heartbeat handles the checking and can assess if the host is healthy or not. So let's say that the host failed, and then the primary storage NFS is the main option to check. But there are some issues with that. It's not perfect. So this is one of the mentions. I think the earliest one that I could find reporting some issues with this is from Nux, a very active contributor and member, which he mentioned currently KVM availability works by monitoring an NFS based on heartbeat file, and it can often fail whenever this network share becomes lower, causing the hypervisor to reboot. So I've seen some cases that the whole cluster went down. It's not common to happen. I was kind of performing some crash tests on a test environment, but it can happen. So that's absolutely true what Nux mentioned. This can be particularly annoying when you have different kinds of primary storage in place which are working fine. So this is also true because sometimes we have multiple storage, and the NFS VMs are just a partition in the host, and most of the VMs might be healthy. And the whole case of high availability is to avoid downtime of the VM. So we're not aiming at the rebooting hosts that have a lot of VMs running. So this particular NFS check might not be the best option in some cases. So let's proceed. So the main question, can we have high availability without NFS? And there are some possible validations. So I raised a few here. Let's maybe just check the agent, which is Java. However, Java can crash. We can have a wrong configuration that changes the Java address or something that an exception that was raised. It's not common, but it can happen. And additionally, we already run some checks, and if the Java is down, we see as disconnected host. So admins can go there and check on their own. So it will be a bit of redundancy, and I think we cannot take that much of the Java VM check. There is also the check storage activity, but it's quite high the cost to implement and maintain because we need to consider a lot of different architectures and storage. So nowadays we just maintain for NFS. That's a problem. And we could check via libvirt. That's interesting, and we could list the VMs that are running and assess if the libvirt is working. So that's a good sign that the host is healthy. If libvirt is not working, so we are sure that something is not right there. And at the end, we could simply ping, but ping is quite limited and often firewall can block and also does not provide much information if it's not working, or if it's working, we're not sure if the network bound is working, but maybe the storage is not working, so that's not the best option as well. So we choose to go with the libvirt validation, so we can have a KVM availability regardless of storage. So this is how it works nowadays, and the proposal is not to remove the NFS heartbeat, but instead to keep this component and add a new one. So we are going to add an HTTP availability helper. It's a Python code that's running on the KVM host, and this Python is basically a web service that is responding some HTTP REST requests. And this REST request says the amount of VMs that are running and can help us to understand if the host is healthy or not based on the amount of VMs that are running, actually comparing with the database and the libvirt, and also if the libvirt is running or not, because if it's not running, we will have some error code there to handle. So one of the main, actually, we also have this neighbor check as well implemented. So we can still check neighbor hosts via one of the hosts. So let's say that this host is problematic, it's failing. So we get one of the other hosts in the cluster, send a comment to that host, and that host can check via the same web service if the problematic host is healthy. Because sometimes it's a routing issue or firewall, something, and this way we can ensure that the management network is working fine at the cluster. So it's just sending the package via the same switch, so avoid some network troubleshooting. And of course, we are going to log it all, so the admin would be aware that it failed via the CloudStack management, but it had success via the neighbor host, so it's not going to fence the host. And all of that's done together with the Nfs as well. So let's pretend that the Nfs check failed, but the high availability helper is saying that everything's okay. In that case, we're not going to fence or recover the host, but instead we're going to mention that one of the checks failed. So the system admin is able to check what's going on. Let's pretend now that the KVM high availability failed, but the NFS heartbeat is working. So that's another point that we are not entirely sure that the host is not available. And we're not going to fence unless we are sure, because it's quite a radical approach to fence or recover a host. We do it only when we have sure that it's problematic host. So if both fails, then we have a situation and we handle that. Okay. In a nutshell, this proposal allows to send some REST APIs to a web service that runs with virt commands. It's pretty much live virt bliss. It checks also neighborhoods and one can enable disable. This is very important. So getting back, let's say that someone disabled this agent. No problem at all. We still going forward with the same workflow. If a cluster has no NFS attached to, there's no problem as well, because this check is going to be skipped with this proposal. Nowadays, the check's not skipped, and this can cause a sort of problems. I want to remove an NFS storage and solve the whole cluster going down. So that's a problem. I see some pull requests already handling some discussions, so that's something that probably soon will be fixed. But this is something that we are trying to enhance as well. Have a sort of parallel checking and mutual checks that help us to avoid issues. Let's go back. So one can enable or disable this agent. By default, it will be disabled always, so avoiding any inconsistency, because it requires the installation of this agent on each KVM node and configuring the ports as well. So we need to make sure that there's no firewall rule blocking this port. If NFS user in cluster, it's also taken account, as I mentioned, and if no NFS user, heartbeat checks are skipped. So that's the main reason we are aiming to have this, because it is pretty much straightforward. One can plug and unplug in real time NFS storage pool, and nothing will happen. The implementation will handle it all, and it will just be a matter of some log messages and warnings in between while the implementation is checking different storage, but that's not really a problem. That's not going to fence or recover any host. And here is some example as well. So pretty much a simple HTTP get to the host, and we get a response with the count of VMs and also a list of all the VMs. And this is interesting because not just provide information that is healthy, but also provide more information like the number of VMs that are running. And this can be used when checking the stats of the host. And comparing with the check neighbor implementation is a different path for the request, where we have the source host, then the path check neighbor, and then the target host. The ports need to be configured, as I mentioned, so that's something that needs to be taken care of. By default, it's 88. And the response then, when we check the neighbor, is pretty much up or down. So we can check if the agent is answering or not. It's pretty much just checking if reachability, and that can help us during the implementation. There are some possible outcomes with this agent. So if the request gets a response listing VMs, and this response matches with database, all good, so no problem here. However, we can notice sometimes that database has a number of VMs. So let's say that NFS crashed. and a partition of the VMs will be down now. But CloudStack does not see this. CloudStack thinks that all VMs are running. And with this implementation, now we get a warning message saying that it does not match the number of VMs on database with the number of VMs listed in libvirt. It's not going to fancy because we're trying to be as careful as possible, but it's good because it's a new information and help admins monitor and assess quickly some issues. And there are situations then that we need to recover or fence the host. This can happen if there is 0 VMs listed via libvirt, but according to the database, there are many VMs running. So this is a serious issue because now we are absolutely sure that there's no VM running there. And CloudStack needs to restart those VMs on another host. We added a safe margin of 1 VM because there are some situations where the libvirt lists 0 VMs, but CloudStack lists 1 because it's pretty much the seed VM, the first VM that's going to that host. It's either being migrated or starting. So there is a slight difference sometimes and inconsistency, but they soon get fixed as soon as the VM gets actually up or paused there. So this also allows us to list libvirt VMs that are running or paused because we know sometimes migrations can take a while. And during the migration, the target host holds a VM as paused. So that also avoids some inconsistency. And at the end, HTTP request gets an error code, for instance, 404. And then the CloudStack management understand that the service is not reachable or something really bad happened there. And either there is no reachability or libvirt is down, basically. So, and then it's a good sign that we need to fence or recover this host. Okay. I went really straightforward here. I think we can use more time discussing and open some questions because pretty much this is the current state and the current issue and the proposal. But for the future, I think high availability systems, they are very critical and we need to pay attention to them. And we always be able to improve because they are complex, critical, and they can lead to some pretty nasty issues. For instance, fencing or recovering all the hosts in the cluster. So high availability can be done regardless of storage. That's another interesting point that we've been seeing. We have been testing this and running in a test environment. But this presentation is not trying to remove NFS storage. It's just a new option. So combining multiple checks can lead to robust systems, and we encourage this. But for now, this is what we can use. For instance, if we have only staff with KVM, so we are now able to have some sort of evaluation of the environment. The code's already available. There's a pull request open, and we aim to implement this for 4.16 or next LTS. We're not sure if we will get in time. And but that's all. I hope that I covered everything. And I'm open to any questions.